So, hello everybody. This is a practice sheet derivative here. If you guys are looking for some practice problems to really work out, I'm going to link a lot of videos and a lot of links to these practice sheets that I've made specifically designed to get you guys really prepared for all the different types of questions on the AP or just any calculus course that really can come up and trick you up. And yeah, I'm also currently working on a website that's about to be published, so keep an eye out for that. If you guys are interested in looking for free practice sheets, everything is free on that site except for private tutoring. So if you guys are looking for tutoring and all that stuff, you can just email to the email that I'm going to have in the description. But other than that, let's get straight into the derivatives worksheet here. So before we go in, here are just some things we got to know. Remember the product rule, which was f times g. The derivative of this will just be f prime g plus g prime f. Remember that quotient rule was f prime g minus g prime f all over g squared. And you know, you can, there's obviously the chain rule that you're going to have to know pretty obviously, and some other things. Okay, so let's get started. So the first problem here is just a very simple power rule. So just bring this power down. It'll be 7 times 5x to the fourth, and that's just equal to 35x to the fourth. There you have it. The second problem is another power rule, but it's just the sum. And remember that the sum of the derivatives is equal to the derivative of the sum. So just do the power rule here. So it's going to be 8x cubed plus 30x to the fifth, right? Bring down the 6. So there's your derivative. All right. Next problem here. Derivative of this entire thing. Well, we can take the derivatives individually. So the derivative of e to the 5x is just going to be 5e to the 5x, right, based off the chain rule, plus derivative of x cubed, straight up use the power rule. You're just going to have 3x squared. And all you're going to do is just add 3 to that, because the derivative of 3x is just 3. Next one. The derivative of e to the negative x squared. Well, this one is just a chain rule problem. So, of course, derivative of e to anything is just e to the negative x squared. But we need to chain rule it. So chain. We have negative 2x, the derivative of the top right here. Better way to rewrite this so that you guys really see what's going on here. It's e to the negative x squared times the derivative of negative x squared. That's what the chain rule is doing. We all know the derivative of negative x squared is just negative 2x. So there's our derivative. Next problem here. We're going to do the derivative of x squared e to the x. I'm going to change the color really quickly. So this is a product rule problem, okay? So we have f of x. Let's say f is equal to x squared, g is equal to e to the x. We're going to do the product rule, right? So for this problem, I'm explicitly going to just write it out. But for the next problem, which is also a product rule problem, we're going to go straight into just figuring it out in our heads. So take the derivatives of each of the functions that we've defined. And so, remember, it's f prime g plus g prime f. So it's going to be 2x times e to the x plus g prime of x, which is e to the x, times f, which is x squared. So all in all, we have 2x e to the x plus x squared e to the x. This is our final derivative. Just going to erase all of this, move this all a little bit here. There we go. So the next one, let's do it in our heads a little bit. So we're going to take the derivative of the first, which is this one. So derivative of 3x cubed is 9x times to the 3 minus 1, which is 2. We're going to multiply that by the second term, which is just keep it there. Then we're just going to add. Now we're going to take the derivative of the second term. Now derivative of e to the x squared, well, that's just e to the x squared, but we need to do the chain rule. We're going to multiply this by 2x. And this is also just going to be multiplied by that first term. And there is your derivative. You can leave it just like that. That is completely okay for the AP. No simplifying required. Another product rule problem here. Derivative of x squared ln of x. Okay, so derivative of the first term is just 2x. Tag along that second term, ln of x. Derivative of the second term is just 1 over x. Tag on the little x squared here. And of course, this entire thing can just be rewritten as x. So there is your derivative. Here we have another chain rule problem, the ln of 3x to the 4th power. Well, the derivative ln of anything is just 1 over that thing times the chain rule. So it's going to be 1 over 3x to the 4th. We need to now do a chain rule here, times. It's going to be 3 times 4x to the 4 minus 1, which is 3. And let's just simplify this as equal to, where the 3's are going to cancel out. It'll be actually just 4 over x. So there you have it. Notice how this also cancels out to that. And there you go. Let's move all of this a little bit up. Next problem is it looks a little bit tricky, but it really isn't. This constant can really just be brought out to the front. So we really have 5 times that derivative. Derivative of this is just going to be 5 times e to the 5 plus 3x squared. Write this a little bit better. But we need to do a chain rule here. Derivative of this inside function here, 5 plus 3x squared. The derivative of that, well, that's just going to be 0 plus derivative of 3x squared. Derivative of that is just going to be 6x. Okay? So there's your derivative. Okay, so now we have a sort of a very difficult problem here. There's a slight typo. I apologize. This will be taken care of. We can just draw a little bit of a white marker there. So we have the derivative of ln of x cubed e to the 5x minus 13. So this is a product rule and a chain rule combination here. So a little bit trickier, but either way, let's do it. Derivative of ln of x cubed is 1 over x cubed, but we need to do a chain rule times 3x squared. Simply multiply that by the second term. Then we're going to add the derivative. Now we're going to take this derivative right here. Derivative of e to the 5x minus 13 is going to be e to the 5x minus 13. Do the chain rule. Derivative of the inside function is just 5. And we're just going to obviously multiply that by the first term that we already took care of. So all in all, this is really just going to be simplified to this first term right there simplifies to 3 over x. And then you can just multiply that. Then we're going to add, this is just going to be 5 to the e to the 5x minus 13 ln of x cubed. There you have it, guys. There's that derivative. Let's keep going. Top right. So this is a quotient rule derivative. So this is the first time we're going to use quotient rule here. The quotient rule is not that bad, not too bad at all. Simply remember the formula, f prime g minus g prime f all over g squared. Okay, so derivative of the top is going to be 2x. Just tag on that e to the 2x. Minus derivative of the bottom. Derivative of e to the 2x is 2e to the 2x using the chain rule. Just tag on that x squared all over e to the 2x squared, which is just e to the 4x by the rules of exponents. There you have it. Derivative of cotan of sine x. I bet you were not expecting a cotangent derivative to show up here. Not something that a lot of people really memorize, not something that's very popular in mathematics at all. But it's still important to know because it can come up on the AP test. Recall that the derivative of cotan x is just going to be negative cotan x cosecant x. Or actually, sorry, that is definitely not true. It's negative cosecant squared x. Why would I? That's a different derivative. Do not think of it. That was a completely different derivative. Even I'm getting mixed up. So we have this derivative right here. So cotan of sine x, well, the first part is doing the outer parts. This is going to be a chain rule, but do the outer derivative. So we're going to have negative cosecant squared of sine x. Now we do the chain rule. I like to do the three brackets, chain, chain, chain. To really help me remember that you need to do the chain rule. Derivative of sine x, it goes in here. This is just cosine x. And there you have it. There's our derivative. Another quotient rule problem here. This one looks a little bit trickier. You have secant of x, once again, another derivative that just isn't as popular, but this one I promise will likely come up more than cotangent, so pay attention to this one. Simply put, this is going to be derivative of secant x is secant x tangent x. Just tag on that little x cubed at the end. Subtract it by the derivative of the bottom, which is 3x squared. Just tag on that secant x again. All divided by, not 3x squared, x cubed squared, which is just x to the 6th. There's your derivative. Another chain rule based problem here. Derivative of tangent of e to the x is just secant squared of e to the x. I am losing a little bit of my voice here, but and of course you just do the chain rule here, and the derivative of the inside function is just e to the x. So this will actually just be e to the x secant squared of e to the x. Okay, so now we have a chain rule and a chain rule. So this is going to be a double, actually it's going to be a triple chain because we have the ln, a tangent, and an x squared. So there's a lot of things that's going to go on here. But do it step by step. Look at the outer function first, the big outer one. What's the last thing you would do if you try to solve and by plugging a number into this thing and finding the value? What's the outer function? It's ln. So first take 1 over whatever is inside the ln, tangent of x squared. Now we need to do this and multiply by the chain derivative of the inside. What is the derivative of tangent of x squared? Well, certainly that's another chain rule problem because secant of x squared is going to come out, but we need to do a chain rule again for that x squared term, and so we have a 2x. So there is our final answer right here. So remember that the derivative of a triple product is eventually just going to be f prime gh plus fg prime h plus fgh prime. So each respective derivative multiplied by the other two. Okay? Kind of easy to remember if you think about it. So let's do the first one here. This is going to be 2x e to the x ln x, right? It's just a derivative of x squared. Just tag on the other two. The second one is going to be e to the x. Well, that's easy. E to the x is just e to the x when you differentiate it. X squared ln x. The last one, derivative of ln of x is 1 over x. And then just multiply the other two. And yes, you can simplify this a little bit. but I'm going to leave it at that. Okay, derivative of e to the cosecant of x. Once again, another derivative that I don't think you expected to really see in a review worksheet. So, e to the cosecant of x. Well, we know that the first term is immediately going to be just e to the cosecant of x. And then we need to do a chain. I'll try to time that. Chain. Derivative of cosecant x goes in that chain. Derivative of cosecant is actually negative cosecant x cotangent of x. That's a derivative that I messed up earlier, thinking it was the derivative of cotan. There you guys have it. Okay, so this one is a little bit more complicated than usual. We have a product and a quotient rule that is going to be necessary. Luckily, there's no chain rule necessary for this problem, but we're going to still do quite a bit of work. So let's find out the derivative of the top here. Derivative of the top is going to be 3x squared e to the x plus e to the x cubed. We're going to multiply that by sine x. Subtract this by derivative of the bottom, which is cosine of x, and just tag on that numerator. All of this is going to then be divided by sine squared x, and there's our derivative. Not too bad at all. Just if you get used to doing a lot of these derivatives, you can do this faster and faster by recognizing what kind of things are going to come up. Alright, simple derivative here, derivative of 1 over x cubed. We're going to rewrite this as the derivative of x to the negative third power. Why did I say equals to? And this is just negative 3 to the x, negative 3x to the negative 3 minus 1, which is just negative 3 over x to the positive fourth power. Okay, we have a sort of a unique problem here. We have derivative of sine of bx squared for all b's in reals. This means that b is a real number, okay? Just means it's any real number. You can think of pi, 0, 20 billion, the sine of 30 degrees, whatever. So it's just going to be a good old chain rule. This is not as bad as people, it looks scary, you know, what is that doing there? This is just the cosine of bx squared, right? The outer function goes first. Chain. Derivative of bx squared is 2bx. So there it is. That's all you need. Now included that because there are going to be constants like a or b or w that are going to come up in the AP test, so just don't be afraid. They're just replacements for actual numbers. Now let's go back to the top here. Another product rule problem. Now we have an exponential here, but a little bit more complicated without the e in the base for this one. So let's do the derivative using this one as the first one in the product rule. So derivative of 5 to the x is 5 to the x ln 5. Just multiply that by the e to the x. We're going to add that by the derivative of e to the x. Just multiply 5 to the x after. So there you guys have it. Okay, so now we have a triple chain again. So this is going to be outer function first. Derivative of sine of anything is just the cosine of that thing. Now we do a chain. Derivative of e to the x squared is just e to the x squared, but we need to do another chain and multiply by the derivative of x squared, and this is just going to be 2x, and there you have your derivative. Let's keep going here. ln of x over x. Quotient rule. So, derivative of the top. What is the derivative of ln of x? That is just going to be 1 over x multiplied by the bottom, and nicely that cancels out. That'll eventually go to 1. Subtracted by the derivative of the bottom, which is just 1 times the top, which is ln of x, all over x squared. This is really just 1 minus ln of x, all over x squared. Okay. now we have x to the e ln 5. Now, this, intentionally, I put this problem here to kind of trip you guys up. This ln of 5 is just a constant. In fact, the derivative here is just ln of 5, which is a constant, times just the derivative of x to the e, which is e times x to the e minus 1. Remember, guys, e is a constant. This is a constant. X squared's derivative is just 2 times x to the 2 minus 1. X to the e's derivative is just e times x to the e minus 1. Nothing different. Another one, pi to the x. Wait a minute, whoa, my head's going crazy. Oh no. Don't be afraid, guys. Remember, derivative of 2 to the x is 2 to the x ln x. So the derivative of pi to the x is just pi to the x ln pi. So in fact, that's what we're going to put here. Pi to the x ln of pi minus derivative of cosine is actually just negative sign. And you may replace this with a positive sign there. Alright, almost done here. Derivative of 2 to the x minus tan x over x squared. Well, we know derivative of 2 to the x is just 2 to the x ln of 2. Now we need to focus on the derivative of this part. Then put in parentheses. So we need to do quotient rule. Now the top, so derivative of the top, which is tangent of x, secant squared x. Tag on that little x squared at the end. Subtracted by the derivative of the bottom, which is 2x. Just tag on the tangent x. All divided by x squared, which is really just x to the 4th. And I'm going to leave it right there. Okay, a little huge triple chain here again. Remember, when you see a triple chain like this, just start very clear, be very direct. Outside function. What is the most outer function? That's sine here. Sine of derivative of the sine of anything is just cosine of that thing. Now we need to do a chain. ln of x cubed. Derivative of ln of x cubed is 1 over x cubed, but we need to multiply by the derivative of x cubed as well, which is 3x squared. So triple chain rule. Alright, so a little simpler of a problem here, just a basic chain rule problem. Derivative of cosine of 5 minus x squared cubed. Well, this is just negative sine of 5 minus x cubed, chain. Derivative of 5 minus x cubed is just negative 3x squared. Don't forget that negative sign, okay? There you have it. Alright, derivative of tan x e to the 2x, just a product rule problem here. Take the derivative of the first guy, tan x, which is just secant squared x, tag on that e to the 2x, add it, take the derivative of the second person, 2e to the 2x, tag on that tan x, and you're good to go. Okay? Alright, last problem, real problem. There's a bonus problem at the end of this video. One more problem here, and yes, this looks a little bit crazy, but just bear with me. This term, I know, looks a little crazy. Yeah. Don't worry, no product rule here, it's just chain rule. So, this is really, and I want to rewrite this as cotan of x, all of this squared. This is the same thing, okay? So, derivative of e to anything is just e to that thing. So start simple, guys. Start with what you know. Now we need to do a chain rule for the derivative of 5 to the x minus 2. Well, derivative of 5 to anything is just 5 to that thing, ln 5. But we need to do a chain rule again. So we need to do a mini chain rule for x minus 2, and that's just 1. So luckily, nothing too much to worry about that derivative. There you go. But wait, we need to add the derivative of cotan squared x. So the reason I wrote it as the derivative of cotan of x squared is now it looks like a product rule. Let me write that a little bit bigger. So it's going to be cotan of x squared, okay? So now you can kind of see how the power rule is going to be the outer thing. So it'll actually be 2 cotan of x to the 2 minus 1, which is just 1. So 2 cotan x. Chain. What is the derivative of cotan x? It's negative cosecant squared x. And there is your derivative. A little bit trickier, but still doable. Now there's one more, maybe not yet. There's one more problem here, secant squared of e to the x. So let's do this problem really quick. Just use a chain rule here. So it will be derivative of, so it'll be 2. So I'll rewrite this for you guys. This is actually just secant of e to the x squared, okay? So now you can kind of see the first step is going to be doing the power rule. So it'll be 2 secant of e to the x to the 2 minus 1, so that's just 1 to the first power. Chain. What is the derivative of secant of e to the x? Well, the first part is just going to be secant of e to the x tangent of e to the x, right? Derivative of secant of something is just secant of that thing, tangent of that thing. But we need to do a chain rule of the inside of that secant function, which is e to the x. Derivative of e to the x is just e to the x. And there's your incredibly long derivative that you don't need to simplify. All right, little bonus problem here, derivative of x to the x. Now, remember that a to the x's derivative is a to the x ln of a, and the derivative of x to the n is equal to n times x to the n minus 1. But there's no rule for when both the exponent and the base are both variables, so we actually can't use any of these formulas here. This is not allowed. So what we're going to do is say, okay, let y equal x to the x. I'm going to show you 2 ways to do this. So here's method 1. So take the ln of y is equal to x is equal to ln of x to the x. So this is ln y is equal to, so we took the natural logarithm of both sides. So now we can use the properties of logs to bring this exponent down. From here, we're going to now take the implicit derivatives. So 1 over y dy dx is equal to, now I do a product rule here. Derivative of the first part is just 1, so ln of x, plus derivative of ln x is just 1 over x, but it's going to be multiplied to the x, so it's actually going to be 1 here. Now, dy dx is just equal to y times ln of x plus 1, but what was y in the beginning? Y was x to the x, so this is just x to the x ln of x plus 1, and there is your derivative. But the second method is probably the one that I personally prefer because it is a little faster. So once again, we're going to have y is equal to x to the, so okay, x to the x is equal to e to the x ln of x, right? This is equal to e to the ln of x to the x. Let's start there, right? So hopefully you guys see that, because e to the ln of a is equal to just a. So we're allowed to write this in that form. Okay, so now we're going to take the derivative of e, and by the way, this is just going to use the properties of exponents, so it'll be e to the x ln of x. Okay. So derivative of e to the x ln of x is now our new problem. And this is very doable because now the derivative of e to anything is just e to that thing. And now we just need to do a chain. What is the derivative of x ln x? We know that's just going to be ln of x plus 1. And from here, obviously, we can just transform this back to x to the x times ln of x plus 1. And we get the same result. So two different ways. One's using implicit differentiation and the other one is using exponent properties. All right, well, there you guys have it. That's the end of this practice sheet walkthrough here. So these are your answers to the practice sheet. So yeah, just keep that in mind. Let me just circle this one. And yeah, so there you have it. The practice sheet is linked down below for you to try. And yeah, have a great rest of your day and good luck on your AP exam.